Here is example number 3 for linear functions, assignment 19 again, folks. We're going to talk about an application now. So, one winter I was looking at our natural gas bills at our household, my lovely Helga and I noticed that they were talking about that natural gas is sold in what's called MCF. It's how much consumption. And so I was thinking, is there a relationship between the consumption measured in MCF and the cost? And it turns out that there is indeed a linear relationship between these two. So in part A here, we're going to build the equation that relates MCF, how much natural gas we consumed in our house, and the cost, two variables. All right, and there is, it turns out, a linear relationship. Now, not all variables are linearly related, but in this example they were. All right, so if you're going to build a linear equation, and now I would invite you to look at the notes that say linear function. If you're going to build a linear equation, I want to remind you that the format is y equals mx plus b. So in part A here, this time we don't have boxes, so I'm going to leave that up for future examples. But I look at it as a puzzle where you're going to build the equation y equals some number times x plus some other number. So it's like it's a puzzle figuring out what's the m, what's the b, fill in the blanks, all right? So here we go, y equals blank x plus blank would be the template for the equation of a line. Find m, find b, that's my thought. All right, so step one on an application, I feel, is to establish your variables. If it's a word problem, what's x going to represent, what's y going to represent? And I would always tell people that the best thing to think about is y per x. All right, I would think about that word and it will help. And that will come into play more and more as we go through these. So I want to remind you that two things are cost and MCF. Keep in mind MCF is how much natural gas we consumed. So I'm going to ask you, and I think you'll tell me, does it sound more reasonable to say MCF per cost? There's one option. Or does it make more sense to say cost per MCF? What do you guys think? I think cost per MCF makes sense. Mr. South America? Cost per MCF. I agree. Cost per MCF. So it seems to me that we would want the y to be the cost, which would be dollars, and the MCF would be here. All right, now I'm not going to say that it's always true, but I think when you're talking about the cost of something, we usually say cost per all the time. At a hotel, we say cost per night. At a gas station, we say cost per gallon. At a school, we say cost per credit hour. You know, that's pretty typical. So I think in a case like this, that seems to resonate. So let's keep that in mind as we go through this, that the y is going to be the cost and the x is going to be the MCF. How much natural gas did we use? So we look at it like a puzzle. Let's start with this. That number that goes in that first blank is our slope. So let's think about what it is that we need to find our slope, otherwise known as m. Well, there's lots of ways to find a slope, but the way we know so far, going back to assignment 18, was we had to have two ordered pairs, didn't we? We had to have an x1, y1, and an x2, y2. So I would suggest to you that's the next thing, is to read the narrative and see if we can come up with a couple of ordered pairs, otherwise known as x1, y1, and x2, y2. All right, so real life here. Let's read. In January, the natural gas bill showed that when we used 12 MCF, it cost us this much. That, in the language of algebra, would be an ordered pair. So that January gas bill would be a pairing of these two variables. And they said 12 MCF, that would be x, and 2324, that would be the y. And I'm looking at that, and I'm thinking, well, that would be an x1, y1, wouldn't it? In the language of algebra. So the January gas bill, in my algebra brain, was an ordered pair. All right? So my thinking went, well, I need an x2, y2, don't I, to get my slope? And so I'm sitting there going, what am I going to do here? And I don't know, I wasn't thinking, but I thought, well, I guess I'll just have to wait for the February gas bill to arrive so that I can get my X2, Y2 and continue. So, my thinking went, well, I guess I'll just have to wait for the February gas bill to arrive before I can do this. So I kind of put this example on the back burner. And about middle of February, when I anticipated the gas bill to arrive, I would camp out at the mailbox. And every day, Kathy, the mail carrier, would pull up, and I'd say, "Kathy, is the gas bill here?" And she'd say, "No, I don't think so." And I'm like, "Man, dang it." And she'd look at me like, "What? You want your gas bill? Are you crazy?" But anyway. And so, finally one day, Kathy pulls up with the mail. I'm camping out waiting so I can finish my math question. "Kathy, is the gas bill here?" And she said, "Well, yeah, here it is." And I went, "Yay, thank you, Kathy." And I gave her a big hug and everything, went running in the house and ripped it open. And I said, "Hey, everybody, guess what? The gas bill's here." And Helga, my wife, looked at me like, "What?" And by the way, I was looking out the window. "How come you were hugging Kathy?" And I'm like, "Yeah, she brought the gas bill." All right? So anyway, in February, the gas bill showed that they charged us $20.40. Now look at that. That's the first number in the sentence, but wouldn't that be the value of y? Because again, so important to remember what the x and the y represent. So that particular month, they charged us $20.40 for 10 MCF of natural gas. Okay? By the way, this is just a portion of the gas bill. In case you're wondering, those seem like really low gas bills. There were other charges on there. We're calculating the cost of gas portion of it. All right, just so you know. But anyway, yay! We got our gas bill. By the way, Helga told me I had the December one back in the file cabinet. I could have probably used that, but I didn't know to ask. But anyway, look, once we have these two ordered pairs in the form of two gas bills, can't we find our slope now, m? And I would throw out there that there's going to be multiple ways to figure out our slope as we progress through these examples. But I hope you'd agree that we could just use the definition on this example that we did on assignment 18, y2 minus y1 over x2 minus x1. So, here we go. Slope, y2, $20.40, minus y1, $23.24, over x2 minus x1. Do the arithmetic. Let's see, 10 minus 12 is negative 2. And this is embarrassing that I have to type this in, but I'm going to. $20.40 minus $23.24 is negative 2.84. I'll stop right here. Remember, the numerator of a slope is change in y, rise, and the denominator is change in x. What happened between these 2 months is our charge went down by $2.84 because our consumption went down by 2 units of MCF. Change in y over change in x, change in cost over change in MCF. And then, might as well simplify that. So I believe that comes out to be what? Positive 1.42. All right, and I would just simply throw out there to you that 1.42 is our slope, and wouldn't that belong right here in our equation? That's where m goes. We're starting to build this equation, right? Yeah, we're building it. I would also interpret this. Slopes, in my opinion, are easily understood if we make them into fractions. What's $1.42 if you made it into a fraction? $1.42 over 1. Everybody's doing this, right? The numerator of a slope is the change in y, and the denominator is the change in x, and fraction bars relate to the word per. Here you go. They're charging us $1.42 per fraction bar every 1 unit of MCF. So actually that's what the business people would call a unit cost. The cost per 1 unit. So when people talk about a unit cost in a business application, an algebra nerd might think, oh, I call that a slope. All right? So anyway, there's another blank to fill in, the b. And I want to remind you that the b over here is called the y-intercept, isn't it? All right, b. And I'm going to leave this template up here for all these questions that we will now enjoy together. Find the slope, find the y-intercept. There are a lot of ways to find the y-intercept. I am of the very strong opinion that the best way to find your y-intercept is to take the equation y equals mx plus b and plug numbers into it and solve for b. All right, so I will now demonstrate. Usually when I ask people, what do you remember about equations of lines, they will typically say, I remember y equals mx plus b. And then I'm like, let's use that. Let's use that. There's another way to do it. It's called the point-slope equation, but that requires more hard drive space. I don't know, I used to teach it. Lots of books do. Do it that way if you want. But to me, it's more things to remember. If you take the equation y equals mx plus b that most people are familiar with, and you plug numbers into it, so how would we do that? Well, first of all, we're looking for b, so that remains the variable, plus b. M, we just determined, was the $1.42. So now the question becomes, where in the world could we get a pair of numbers to plug in for the x and the y? Where in the world could we get a pair of numbers to plug in for the x and the y? Oh yeah, those ordered pairs. Now, it doesn't matter. We can pick either the January or the February, flip a coin. I would pick the one where I think the numbers would be easier to work with. My opinion would be, even though we could use the January one, I'm going to use February because I'm noticing that if you put 10 in for x, it's easier to multiply things by 10 than it would be to multiply them by 12. So pick one of the 2 points. Flip a coin. All right? If you have a hard time making decisions in your life, flip a coin. All right? That's how I decided to take this job. And unfortunately for you, it came up heads. All right? But anyway, that ordered pair there, the x would be 10 and the y would be $20.40. Plug it in. Could we use the other one instead? Sure, it'll work, I promise. Then you might say, why do we need them both? We needed both of them to get our slope. So you had to have them both, but in this step, you only need one of them. Flip a coin, all right? So anyway, then you do a little arithmetic here. For example, you take the $1.42 times 10. So 2040 equals $14.20 plus b. Solve for b. Subtract over the 1420, in other words. And it looks like b would equal $6.20. There's b. So we put it in here, $6.20. Yay! All right, so there would be our generic equation. This is where it's exciting. This is where you get goosebumps. We only had 2 observations here, the bills for January and February, but now with that equation, can't we calculate any gas bill for any month? And that would be the idea. Once you build the equation in part A, then we'll go, okay, now enjoy that equation you just built. What would be the cost of 15 MCF? So, what I did is I went out and I looked at my gas meter in March, and I looked and I read it. I don't know how to read it. I'm making this up. Just play along, okay? I read the gas meter and I said, oh look, we've used 15 MCF. I can use that equation I built back in February to figure out what our cost is going to be on our next gas bill. All I got to do is put 15 in for X here, right? So the cost, Y, would equal $1.42 times 15 plus $6.20. And do arithmetic there, right? I've kind of painted myself in a corner, but you take this times 15 and add this, and Y would equal, wouldn't it? And so, here we go, $1.42 times 15 plus the 620, $1.42 times 15 plus the 620, and I wanted to make sure I did that again correctly, $1.42 times 15 plus, no, I put that in wrong, I better do that again, $1.42 times 15 plus 620, and it looks like it would cost us that month $27.50. So that's what people do. They use 2 observations to get a general equation that they could then use to do any gas bill. So Y equals the cost in that particular month would be $27.50. So there you go with that. I think that would take care of that one. I'm trying to think if there's anything else we need to talk about. I don't believe so. So we'll just kind of walk out of here. We're not going to graph that one, but oh well, I got music in case we were going to graph it. Graphing the line. Graphing the line. Graphing the line. Ask your grandparents, all right? Tommy James and the Shondells, all right? Graphing the line.